Hello students, this is Shadari. In this video, we know about the homogeneous coordinate. Okay, let's start. What is a homogeneous factor or coordinate? It's a way of representing points that makes a geometrical transformation like translation, rotation, scaling, and projection in a matrix multiplication. Focus on a matrix multiplication. Why I am saying this? With the homogeneous, the translation in a 2D translation, we know about the translated parameters like t of x, t of y is adding with the x and y coordinates, right? So here with the help of homogeneous coordinate, we take the translation parameters in a multiplication of a matrix. Okay, I think this is clear. In a short way, it is understood that the homogeneous coordinate representing a simplified perspective transformation. Okay, this approach is which normally must be expressed as an addition in a translation, right, can be represented as a matrix multiplication using this homogeneous coordinate. Okay, so how it is denoted and what are the notation or how we have to denote the homogeneous coordinate with the W or H, we can initialize that one. Okay, for that reason it makes the a 3D into a 4D vertex and 2D into 3D vertex. Okay, so however the certain situation where it is useful to think the in terms of a projective geometry. Okay, means how it will displaying the geometrically has a it use a extra dimension called a W or H. In addition to the x, y and z dimensions, the fourth dimensional space is called a projective space. That coordinate in a projective space are called a homogeneous coordinate. Okay, so how we have to representing the given image with the homogeneous coordinate? It simply translate using a translate it will adding the matrix, right? With use the homogeneous we multiplying that one, and for this it will give the a unique means a same equation, or you can say same method of a matrix multiplication. Okay, so next, the instead of a separate equation for a translation means that is addition, and scaling, rotation and remaining transformation is in a multiplication, right? So using this homogeneous, we are using all the transformation processes of a matrix multiplication only. So, so it will represent 2D as a 3 into 3 matrix, 3D in a 4 into 4 matrix. Okay. So the standard value of a homogeneous is 1. Why we are taking 1 means it will not affect the changing of any value, means 1 is give the standard one. If you negatively give means it will impact on the display, means the geometrically the dimensions get changed. That's why you do not take any value, it will take a standard 1. So this is a 2D transformation t of x, x plus t of x, y plus t of y, right, without homogeneous. What we using a homogeneous coordinate, we are multiplying this matrix. Okay, so this is how we have to represent the matrix. In 3D we have to use x, y, z and a homogeneous, it will give this equation. This is a matrix of a transformation translation. Okay, so how to write the other matrix for other scaling and other transformation process? Here is the representation of a 2D and 3D matrix of a with the homogeneous of a scaling. This is a 2D x and y. This is a homogeneous coordinate. So 3D it will give x, y, z and a homogeneous. This is your equation. This is how you have to write the matrix. So this is for a clockwise, anti-clockwise as a 2D, and this is for your 3D. On x-axis, x will be 1 and y and z coordinates will be changing the values of a cos and sine. And this is for a y-axis and this is z-axis. Okay. So the method is same with the matrix multiplication. Instead of 2D, we are applying 3D operations of a homogeneous in a 2D and 3D is a 4. Okay, this is for a sharing, 2D sharing, and this is for a on x-axis y x and y and z sharing. The matrix is like this. Okay, so how it equation will be formed, we will discuss in a next video. Okay, so here I am providing all the matrix representation of a 2D and 3D with a homogeneous coordinate. So refer this one and we'll simply take the matrix. Okay, and reflective will be in a xy, yz and zx plane. So in that this is a xy plane, this is for a yz axis, and this is your zx. Here whatever the plane is there, xy means a z coordinates get a negative value, and yz means x will be negative, and zx means y is not there, so that value become negative, and other are similar as a 2D one. Okay, I hope this is clear. We will see in a next video. Thank you.